Hi everyone. In this video I'm going to do two problems where the augmented matrix corresponding to the system cannot be completely diagonalized. So we're going to see how to identify a solution if there is one, or to say that there is no solution once we get to the end of the Gaussian elimination process. For this system, I'm going to write the augmented matrix. I have 6, -2, 2, 4 is my first row, 3, -1, 2, 2, -12, 4, -8, 8. And I'll draw my separating line. So in the top position, I'm going to multiply 1/6 row 1 to turn that into a 1. This is my pivot position. 6 times 1/6, -2 times the 6th is -1/3. 2 times 1/6 is +1/3. 4 times 1/6 is +2/3. And the other two rows I'm leaving alone. Next, I want to make zeros below that pivot. I'm going to take row 2 plus -3 row 1. That'll make the 0 in the second row. So 1, -1/3, 1/3, 2/3. There's my matrix. Try and squeeze it in here. Okay, -3 times 1 plus 3. -3 times a third, that's +1 and -1. This gives me a 0 in that spot. -3 times a third, that's -1 plus 2 is 1. And -3 times 2/3, that's -2 plus +2. In the third row I have a -12, so I want to add a +12. Row 3 times 12 row 1. Running across row 1, multiplying by 12, I have 12 plus -12. 12 times -1/3, that's -4 plus +4. 12 times 1/3 is 4 plus -8, that's -4. And 12 times 2/3 is 8, plus another 8 gives me 16. Now notice in the second column I have a 0 on the diagonal, and I look below to see if I can interchange rows to get a pivot up on that diagonal of the second row, second column, but there's a 0 below that. So what I'm going to do is go over to the third column, staying on the second row, still looking for a pivot, and there in the third column I'm going to use that 1 as the pivot, and I'm going to, it's already a 1, but I would try and turn that into a 1 if it weren't, and I will make a 0 above and below it. So with that in mind, I'm going to take row 3, and I'm going to add 4 row 2 to make the 0 below that pivot, which is now in the third column. So I'm going to have 0 times 4 plus 0, 0 times 4 plus 0, 4 times 1 plus -4 gives me the 0, and 4 times 0 is 0 plus 16, puts a 16 in that spot. Now at this point I'm going to stop, because I can see that this system is inconsistent. My last equation down here says 0x plus 0y plus 0z equals 16. In other words, 0 equals 16, which is impossible. It doesn't matter what values I put in there for x, y, and z. That will never be satisfied. So my conclusion here is no solution. and the system is inconsistent. I call it inconsistent when there is no solution. Okay, in this system I have two equations and three variables, x, y, and z. And I'm going to write down the augmented matrix first and then do some row operations. So 1, -3, -5, 0, -2, 7, 11, and 3. There's my augmented matrix. I have a 1 in the pivot position, and I'll use that to make a 0 below it. Row 2 plus 2, row 1. We'll put the 0 below. 1, -3, -5, 0 is the first row. That stays the same. I'm going to run across the top row multiplying by 2. So 2 times 1 plus -2 gives me a 0. 2 times -3, that's -6 and 7, puts a 1 there. 2 times -5, that's -10 and 11, puts a 1 here. And 2 times 0 is 0 plus 3. Now I move over to the second column, and the pivot there is in the second row. It's right on the diagonal, and it's already a 1. So I'll use that 1 to make a 0 above. I'm going to take row 1 plus 3 times row 2. 0, 1, 1, 3 is the second row. Going across the second row, multiplying by 3 and adding it to the entry above. So I have 0 times 3 plus 1, 1 times 3 plus -3, 3 times 1 and -5, 3 times 3 is 9, and 0 gives me 9 in that position. So now I'm at the end of my Gaussian elimination process. I have two columns in proper form, and this one right here is not in proper form, and what that tells me is the variable that corresponds to that column is a free variable, and in this case that's z. So z is free. That means it's going to take on any real number value. And the other two variables, x and y, are called basic variables, and they will be written in terms of the free variable. So to get the general solution, I first write the equation from that top row of the matrix just like it is. It's 1x plus 0y minus 2z equals 9. Second row, I have 0x, 1y plus 1z equals 3. And from these two equations, I'm going to get an expression for x and for y. My general solution starts out like this. X equals, y equals, z equals. I have to say something about all three variables that are in my equations. So x, I'm getting from this first equation. I add 2z to both sides, and I get 2z plus 9. From the second equation, I'm going to subtract z from both sides, so I get -z plus 3. And z is any real number. That's my general solution, and now I can find a few particular solutions by substituting something in there for z. So I'm going to make a little triple here. I'm going to put a 0 in for z and then solve for the other variable. So x is equal to 2 times 0 plus 9. That would be 9. y is equal to negative z, z is 0, plus 3, I get 3. So when z is 0, I substitute that into the general form over here and come up with my values of x and y that correspond to that. I can put in any number of values here and come up with solutions, as many as I want. There's an infinite number. So let's look at one more solution. If I put 1 in there for z, then here I have 2 times 1 plus 9, that's 11 for x. And for z, I have negative 1 and 3, that's 2. So here's a second solution, and that is where z is equal to 1.